My name is Patty Lewis, and I will be the moderator of this workshop. First of all, we're pleased to be part of Luxembourg Internet Days yet another year. So a lot has happened at F5 since last year. We have acquired two new companies, Volterra and ThreadStack, over the course of this past year. And just yesterday, F5 announced a change of name from F5 Networks to F5 Inc. And this is signaling a fundamental shift. So F5 is aggressively evolving from traditional load balancing hardware-based solutions to cloud-native, multi-cloud, and cutting-edge solutions. Very much in line with the market trends and what we hear and see from our customers and install base. So 85% of organizations will be cloud first by 2025, and 95% of the new digital workloads will be deployed on cloud native platforms. And this is according to Gartner. So the digital transformation pressure that is ongoing, plus the combined pandemic driven changes that have existed and will further continue, will move us to a world where everything that isn't cloud is considered legacy. So without further ado, I'd like to introduce my colleague Koen VANDERPOORTEN. He's a senior solution engineer at F5, and he will walk us through this very interesting topic, multi-cloud versus multi-cloud, making it easier to bridge the gap. So over to you, Koen.
Thank you very much, Patty. Can you hear me?
Yes.
Okay, perfect. Yeah, thanks for the introduction. So I'll be talking about, or the title rather, is multiple clouds versus multi-cloud. So that means that it's two different things. What we see indeed is that customers are embracing on one side multiple clouds, and on the other side, what we call modern workloads. And there is a relationship between those two, as we shall see. We'll talk about the current approaches to multi-cloud that a lot of our customers have and the problems with those. And then I will focus on how we approach it. And you also already mentioned the name Volterra, and that is indeed the solution I will be talking about today. But first, let's set the stage by defining what we mean by multiple clouds versus multi-cloud. Multiple clouds is, when a customer of ours, most of those, when they start moving to the cloud, they select one vendor, Azure or AWS, and then they try to stick with it. If they have an application that they move to the cloud, all the elements of the application are within that cloud. After a while, they may be adopting other clouds like AWS or Google Cloud Platform, but there's still silos. That means that if you deploy an application in a cloud, all the parts are within that cloud or maybe stretched out to your local network, but it's still pretty much a siloed operation. Nowadays, what we are evolving to, and that is driven by modern workloads or microservices, is that we will start to integrate all these clouds. So we will have integrated operations with part of your application living in Azure and another part of the application, for example, living in AWS. We call that multi-cloud. That is our definition of multi-cloud. And you will see that this brings quite some challenges with regards to operations and security that will need to be tackled. So what does a modern workload look like? Let's first take a step back and look what we have or what we had until very recently. We were working with monolithic applications in our data centers. That means one big block of code, millions of lines long, that is running on hardware or a virtualization platform within your data center. Now, we know that such applications are typically hard to maintain and to upgrade or to deliver new versions, because you have different teams running or working on the same code. And that means if you need to create an upgrade, there's a lot of interdependencies to be checked. And typically, such an upgrade or a delivery of a new version can take up to 6 months or 1 year. So that is why microservices or modern applications appeared, where that big block of code has been split up in smaller pieces. And all those smaller pieces have different teams that can work on those. So that means that upgrades can go a lot faster. Typically, those pieces of code are then put in containers, and so they can be very easily run on different platforms or in Kubernetes, and it makes them very flexible and, let's say, cloud fit for a cloud. Okay, so it's easy to port those applications to a cloud. Now, the cloud or the with regards to infrastructure, we think about the data centers which are still around, obviously, or private clouds. You have the public clouds now that are taking off inside Luxembourg. But there is also a new evolution called edge computing. And the reason for that is users or users expect a very good performance of your application. So the closer you manage to put your application to the user, the better it will perform. And that is why a front end of an application, for example, can be moved as close to the customer as possible to an enterprise edge or to a service provider edge. So with regards to the requirements, you need to be able to distribute, to create this distributed deployment, and to have that front end of your application living on the edge or in a public cloud, and the back end living in your data center. You need to manage this multi-cloud environment, even more than, it's not only the clouds, it's also your data center. And most importantly, and we will focus on that, is you need to be able to interconnect all of this in a secure manner and make sure that it works flawlessly, not only on a networking level, but also on an application level. And that is where the challenges typically come in. So to take a step back, we started with data centers, with server farms running our monolithic applications. Next step was single cloud and an internal private cloud. Customers then started to adopt multiple clouds, often driven by the fact that, if you need a specific functionality which is not available in Azure, for example, you may find it in AWS, or just because of the personnel. If you hire somebody who is very fluent in Google Cloud, for example, you may start to deploy new applications inside Google. But that is still multiple clouds. What we see now is that distributed cloud, where your application or the parts of your application start living in different parts. Could be a data center, a Google Cloud, the enterprise edge, maybe the telco edge, could even be nomadic. It could be a robot or a truck where you have a server running that runs a front end of a multimedia program, for example. So this distributed cloud architecture requires multi-cloud networking, and that's going to be a challenge for a lot of customers. And I'll point that out, why that is specifically. But first of all, let's think a little bit about what are the scenarios? Why would customers, or what types of customers are being used by what types of architectures are being used by our customers? Well, there's different setups, of course. You have customers that move their applications from a data center to the cloud because of functionality or cost reasons. But even then, it's still it already starts to become a little bit complicated because often parts of the application need to stay inside the data center. And Luxembourg is a very good example of that because of all the confidentiality rules, the GDPR, etc. And maybe in your application, you have confidential information that you do not want to put on the public cloud. So that means in reality that you will have the front end of your application running in Azure or AWS, but your database with the confidential information, for example, running in your private data center. Another example could be a cloud-to-cloud deployment. And so you have a front end running in Azure, the back end running in AWS, for example. Why would you do such a thing? Because some functionality can maybe only be found in Azure or in AWS. Or maybe, as I say, you have personnel that is very fluent in one of those clouds, and you start to deploy, or you just start very naturally adopting new clouds as you go along. And finally, we have the site to cloud, what I was already speaking about. Edge computing comes to mind, where you want to bring part of your application to the user as close as you possibly can. Now, what is important to know here, we are talking about applications. So not only will you need the network connectivity, but you will also need the services, or more specifically, the application services, like load balancing, like WAF, etc., etc. So how do organizations typically tackle this? Well, they use whatever they currently have. For example, they start setting up virtual routers on both sides, and then they use infrastructure automation tools like Terraform or Ansible to automate all this, to make sure that it runs fine. But as you can see, there is lots of work to be done there. It's all open source, so it's not always as dependable as it should be. Other customers look at parties like Equinix, for example, who can deliver interconnections between multiple clouds or between their local data center and their clouds. Or you have also SDN platforms that can extend to those public clouds. But often we hear from customers that they run into limitations if they try to do this. There's also another approach, what we call the ostrich approach. That means just do nothing, because it's so difficult to set up this multi-cloud networking that we'd rather keep our applications inside our data center, or maybe in just one public cloud. But that is missing out in the end. If I were me as a user, I could decide to just use my mobile phone and not adopt a smartphone. And I would be able to phone, obviously, but I would be missing out on not a lot of new services, and which would make, in the end, my life a lot easier. And it's just like that with multi-cloud networking. If you are not adopting it, you will be left behind in the end. So let's look at the challenges. There are a couple of bullet points that have been identified by Gartner in this report, the market guide. So the first, there's a couple of points there. The first is, let's say, what they have seen is almost all clients, are interested more and more in adopting multiple clouds. And so that's an evolution that's here to stay, will not go away. Now, the challenges are, if you will adopt Google Cloud, if you are using Azure, Amazon, all these clouds function in a different way, and it will give you operational challenges because you will need to master all those technologies. In the end, it's all load balancing or routing, but every vendor approaches it in a different way. Traditional virtual routers often don't meet the requirements. They are too limited. And when it comes to architecture, there are operational gaps. So that's also a problem. And then in the end, even if you look at, for example, a native load balancer or a native WAF, customers often see shortcomings. So they are missing features that they got used to when using on-site equipment like Big IP or next generation firewalls. So the market needs a different approach. That's basically the bottom line of this study from Gartner, both functionally and operationally. So what does the market need? When we have identified the challenges, which are the different networking capabilities within the public clouds and the complex configurations that you may face. Let's say that in this case, for example, you want to connect an application in AWS to one in Azure. You will need to set up the routing part with the firewalling, etc. But that's only parts of the plan, obviously, because you also need the application services. There might be challenges with overlapping IP spaces, encryption of the traffic between the two applications, etc. So it will work in the end, but it's going to give you a lot of operational costs. And in the end, it's difficult to keep an overview on this because if anything goes wrong, troubleshooting this is quite complex. So the solution that's needed is we need something that can abstract away the complexity of the underlying cloud networking. It should be cloud agnostic, let's say it like that. You need a centralized policy, both for the networking part and the security services that you want to run on top. And you need all this in one single space where different teams can work together. So this is our solution. This brings me basically to our solution that we propose. At the left, you see what I was describing until now, how it's been done until now. So you have one team or different teams managing different clouds with their own technologies, their own GUIs, their own API endpoints, etc. What we offer is, let's say, an abstraction layer on top of all those technologies, those different technologies, with one single interface to interact with. So these NetOps teams, the SecOps and the cloud architects, they have one centralized management platform that they will use. And from there, they will manage all the different clouds, all the different application services, the routing, etc. And it's all abstracted away. So you don't need to be fluent in Azure or in AWS to set up very complex configurations. So let's go a little bit into detail. First of all, what is important is that there's two aspects to running applications. First of all, you have the networking part, and then you have the application part. So in practice, you will need to be able to connect different virtual networks together. And in this slide, the red one is an Azure VNet. The green one is an AWS VPC. It's the same technology, but it's the terminology and the way to handle it is completely different. On the other hand, you need to be able to connect applications. So you need the application-centric approach. So in the end, what we need, or what a customer needs, is something that is cloud agnostic, that has central management, that is easy to use, and which integrates natively with all those different APIs, so that you don't have to connect to the Azure or the AWS GUI to do something. I've been speaking about application to application traffic until now, but let's take a step back, because there is more to that. And we also have user to application traffic, obviously. And let's quickly have a look how that works. And so in this case, you have the user and the application. The application is typically living in a data center or a cloud behind an ADC load balancer, and is published on the public side. You have the VIP, the virtual IP, that is accessible from the internet. Now, in this case, the application is accessible from the internet, if publicly accessible. So I will publish the IP address on a public DNS. And the way a user will connect is by sending a DNS request to the public DNS server, receiving the VIP address, and then connecting to the ADC. The ADC will do its magic, the load balancing, the WAF, the authentication, all the other nice stuff, and only then it will proxy the connection to the inside. So this is the client side. But let's say that my application, I want to divide it in two parts. I want to have a front-end part and a back-end part. How do these two parts talk to each other? Well, it's basically comparable with one important difference. The backend of my application will never be publicly accessible. So I'm not going to publish the IP address on a public DNS server, but a private DNS server. And the private DNS server will be consulted by the front-end app, which will then access the VIP that is in front of the backend. So if we put this in one single drawing, we have the logical model that we want to deploy. Now let's say that the front end of my application lives in my data center on site, runs on VMware, but the backend of the application lives in the cloud. How am I going to set that up? Well, let's just split this application into or this model or this architecture into two parts. The front end, it runs in my private data center on VMware. And together with this application, I'm also going to deploy what we call at F5 the Vault Mesh. And this is part of the Volterra technology. And you could see it as a networking device, a virtual appliance that you deploy there. It will connect to the Volterra network, more about that later, and it will also start service discovery. So it will know about the DNS records, the applications that run on the VMware. On the other hand, the egress or the backend, I'm going to run that in AWS, and there I will also deploy the Vault Mesh part. Again, the virtual appliance that's going to connect to the central manager and at the same time do service discovery. And I could have a third one running in Azure, maybe a database that's running in Azure. So I have now 3 endpoints, all connecting back to a central site. And then from that central site, you as the administrator can start to build connections between those different parts over the Volterra app to application delivery network, which is our backbone that we have running all over the world. So we have high-speed connections to AWS, to Azure. We can have it inside your data center, for example, or to SaaS vendors. And those will all be connected together in one logical overlay network in order to simplify management. So in the end, you have distributed networking and security services extended from your data center to the public cloud. The pillars of this solution, there's 3 important parts. We have the Vault Mesh, which is the virtual appliance, can run on-site or in your cloud, or in your public cloud, or in our data center. And it can do layer 4 up to layer 7 duties. So it can function as a router, a firewall, but also WAF, DDoS, ADC functions, etc. Can do all of that stuff. You also have centralized management, obviously, because the Vault Mesh appliances will connect back to a central point, to a SaaS platform, which is our Vault console, where different teams can interact with it. And finally, you have our global application delivery network that connects it all together. So this gives you consolidation of different networking functions, or rather not only network functions, but also application services. It gives you operational simplicity because you have only one pane of glass through which to do all the monitoring and the management. And you have the common tooling because you don't need to be fluent in Azure or AWS technologies anymore, because it will all be abstracted into one single technology. Logically, so which types of functionality can we deliver? We do virtual routing between those different sites, as you have seen. We can also do the load balancing, both globally and locally. And so that means accessible via the internet or only privately accessible. We have a bunch of networking and application security that we can easily apply. And of course, we are now implementing our own F5 technologies inside this new technology. And so we have recently ported our WAF capabilities inside Volterra. We are doing the same with our DDoS, and obviously this will go on in the future. And then there's another functionality that I have not hinted at, but this solution also allows you to manage Kubernetes, to manage application services wherever you want them. So imagine that you have a distributed application where the front end of your application lives in Kubernetes on the edge, for example, and the backend is also a container living in your data center. And we can extend that Kubernetes across our network so that it's one single big multi-cluster service mesh. So it opens up a world of new possibilities. Just to show you, we have at this moment 21 regional edges. So those are our POPs across the world. And so that means that wherever your application lives, it can always be as close to the user as possible. We are in the process of extending this network as well over a multi-terabit private backbone. Couple of screenshots, but just to give you a flavor. This is a map view, and that shows you where the endpoints or the different parts of your applications live. This is worldwide, obviously, but it could also be inside a country. Imagine that you have a retail network where you have different shops and then a backend in a private data center. A map view like this could be handy as well, obviously. This is more logically, and the gray line in the middle is our backbone, and then you can see that you have the different Vault Mesh appliances living in different sites and all dual homed to the backbone. So that means that you will have a high available connection to the backbone or to the backend of your application, for example. And this is more like a functional view. How is my application working? The different parts of my application spread out over those different sites. Is the interconnection okay? Is there any latency, etc.? You will all see that in this view. To close this off, let me give a practical example of how this would work. I was talking about a retailer. Let's say that this retailer has two data centers living in public clouds in AWS, in Azure, for example, and you have 50 shops. And in the shops, you want to deploy the front end of your application, and the back end of your application is running in AWS or in your private data center, maybe. So what you will do is, in all those shops, you deploy the bare metal, and on the bare metal, you deploy the Vault Mesh appliance. Once deployed, the VoltMesh appliance will connect back to the central management tool. You do the same in the public cloud and in your private data center. And from that moment on, you will have a link between all those 50 shops and your public cloud. And it's very easy now to start deploying applications from the Vault console. This is a multi-tenant console, so you have dev teams and cloud architects working at it at the same time. So in this case, I have made the front end of the application accessible for users. And I have also applied some application services like a WAF, for example. And then second step is with one single click, I can create a route or a data path between the front-end application and the back-end application, wherever it lives. Is that Azure? Is that a private data center? I don't care. And then obviously, once that is running, you have all the insights to manage your application. You have the analytics to improve your applications, etc. No matter where it lives. So in order to summarize, because I see we are it's time, let's put this all together. So this is the general overview. If you start from the center, you have one single pane of glass that allows you to connect all these different locations together with VoltMesh appliances. Or you can use our POPs, like these users on the left top. They can directly connect to our POPs in local data centers or at local, let's say, service providers. And for right now, it's very easy to publish your applications, no matter where they live, by just abstracting all the networking from it and leveraging our application delivery network to put it all together. So in the end, what do we deliver? Network-centric and app-centric multi-cloud networking. Very easy to use, cloud agnostic, as it says. So that will reflect in lower operational costs, obviously. A global backbone with private peering. We also peer to major SaaS platforms like Concur or Salesforce, for example. And a full layer 3 to layer 7 services stack that allows you to have a good overview, to have deep analytics, and to have a very good user experience at all time. That's it for me. Back to you, Patricia.
Thank you, Koen. Very interesting. I realized this is just the tip of the iceberg. So it was a short workshop. And I also know many joined late or were not able to join. It's a good packed agenda. So for all of those that have we're happy to have a one-to-one workshop with you free of charge, of course. So feel free to send me a connection request or drop me a message, and we can schedule a workshop 1 hour and a half, maybe 2 hours, dedicated with you and your teams. So thank you for joining the workshop, and I wish you're enjoying the rest of the event.
Thank you
Good
very much.
afternoon.
See you later. Bye.